Hello learners, welcome to the next session of machine learning in quantum computing. So in this session, we are going to see about what is machine learning, what are the different kind of machine learning is there, and we are going to learn about the basic definitions of machine learning like loss function. First, what is classical machine learning? As per the definition, classical machine learning refers to the algorithm that learns patterns from the data and make predictions or decisions without being programmed. So, as per the rule, machine learning is very important to analyze all kind of prediction, which includes different kind of techniques, supervised, unsupervised, and reinforcement learning, which predata of the deep learning revolution. We have different kind of examples are there. The first one is spam email classification using support vector machine, predicting house prices based on the features like size, location, and number of rooms using linear regression. Linear regression is one of the important supervised learning methods. So in the classical machine learning, when we are entered into all kind of problems, we need basic terms. The first one is what is data. Data refers to the collection of raw facts, numbers, or observations that serve as input to machine learning models. Then, what is the type of data? Structured data and unstructured data. Structured data means tabular data with rows and columns. We have a different kind of data are there. For example, sales record, climatical data, exam mark result. We have many examples are there. For unstructured data, we can have different things. For example, social media post, text, images, and audio. So we can go like that for unstructured data. For structured data, here we have some of the example age. Here we have the age 25 and 13. And with compared to income, here we have 45K and 12K. And own car, we have yes or no option is there. Next is feature vectors. So actually what is the definition for feature vector is it's a kind of numerical representation of data points used as input for machine learning models, because this feature vector is very important for machine learning building. Machine learning model building. It is created by selecting relevant features. That is, we are going to work with characteristics from raw data. For example, here we have a house price prediction is there. In the house price prediction, raw data is to be considered as a 3-bedroom house in the city center with 2 bathrooms and a garden. This value, this raw data to be represented by feature vector 3 bedrooms, 2 bathrooms, 1 garden and 1 city. So this is the way we can represent the raw data from feature vector. Then what are the different types of machine learning is there? The first one is supervised machine learning. Definition means models learn from the labeled data. Labeled data means all the data which is having their class label. The example is linear regression for predicting house prices, support vector machine for classifying disease. These two examples are the best example for supervised learning. Next is unsupervised learning. Unsupervised learning, as per the definition, the models find the patterns in unlabeled data. The data, that means the raw data which does not have any labels. Here we have some of the examples to find out unsupervised learning methods. The first one is k-means clustering to group the customer based on the behavior. The next is principal component analysis for dimensionality detection. These are the techniques we can go with unsupervised learning. In case of k-means, it is very important for grouping of all kind of data. For example, if we are going to search any products in Amazon, the previous history to be analyzed, and based on the previous history people are analyzed and formed as a group of clusters to find out the next product. Next is reinforcement learning. This model learn by interacting with the environment, receiving rewards for corrected action. Example, training a robot to navigate a room, optimizing game playing strategies. Next, the very important metrics in machine learning model is loss function. In the machine learning, the loss function is a mathematical function that measures the difference between what is the actual predicted output of the model and what is the actual target value. This is very important for all the machine learning model. It is very useful how well or how poorly the model is very fit for the data set. The goal of the training of a machine learning model is to minimize the value of the loss function. That is very important here. We need to minimize the loss function so that only we can increase the accuracy of the prediction. So this loss function can be classified as two types: regressive or loss function. This is specially for continuous output. Here we can measure mean squared error, MSE. So this is to be represented by formula, and here we have some limit is there from ni to 1. Actually this MSE is defined as the average squared difference between the actual and predicted values. And the next is mean absolute error. It computes the average of the absolute difference between actual and predicted values. This is also very important to measure all kind of loss function in machine learning model. And next is loss function in machine learning model second types. Cross entropy loss. This is specially used in classification problem. For example, regression, predicting house prices, we need to minimize MSE. Classification, identifying spam emails, that is very important application. Here we are going to minimize cross entropy loss. So choosing loss function is very important based on the problem type, whether it may be a regression or classification. So the model requirement also, we need to think that when you are working with the loss function, whether it is a neural network or it may be anything. And for outer layer sensitivity also, we have to think about MSE is more sensitive to outer layer than MAE. Mean squared error is more sensitive to outer layers than mean absolute error. So we need to optimize the process. So loss function are very much used during training process. So we can go for gradient descent method. This is one of the method to minimize the loss by adjusting the model parameters. In every model we have many parameters, they are there. Based on the adjusting the model parameters, we can go with the gradient of the loss function. And steps of ML workflow. ML workflow is very important. So the first one is data collection and preparation. Collect the data from various sources, handling missing values, outliers, and then normalize and standardize the data. The next thing is feature selection and engineering. Select relevant features and create a new one if needed. For example, converting timestamps to hours, days, or months. The third one is model training and validation. Split data into training and testing set. Train the model on training the data and validate the performance of its testing data. Next, model evaluation. Use the loss function like MSE and RMSE, accuracy, precision, everything is used to evaluate your model. And we have many applications are there in ML. First one is healthcare, predicting patient readmission using logistic regression, segmenting patients for personalized treatment using k-means. Here we have a grouping of cluster is there. Next, finance, fraud detection, and credit scoring using random forest. The third is retail, product recommendation using collaborative filtering, sales forecasting using linear regression, and the fourth one is transportation, predicting traffic congestion using SVM, optimizing routes using reinforcement learning. So we may have a different kind of challenges there. Data quality issues. The first one is noise, missing values, and imbalanced data set can degrade the performance. That is very, very important. And outer fitting and underfitting is also there. Outer fitting, the model performs well for training data but poor for new data. Underfitting, the model fails to capture the patterns in the data. And next, the model interpretability. Complex models can be a challenging. For example, here we can go for ensemble methods. And for the scalability, large data sets and high dimensional data required for computational resource. So with that introduction, we had entered into what are the different kind of machine learnings are there. Thank you, learners.